Okay. So here we go. So if there is no child, if a parent doesn't have child at that time, what it is to, if at all if your node doesn't have a child, then here so as I said, here what it will do is the parent will now have this. The parent who is pointing to X will now have null.
Yeah. Yeah.
Okay. Similar. Now this is clear, right? If a node doesn't have a child. Now, if a node have one child.
Well.
Okay. So that means if one child, in the sense if X is equal to null, that means if and if right is not equal to null, that means if it has right child.
Okay.
Okay, if a node has only right child, at that time this condition will be true.
Okay.
Left child null, right child not null. That means a child is there in right side, one child. At that time, here now here what we are doing is we are seeing that again. Actually, I think I have written something wrong. Why? Because if at all, if we know that whether the child is left child or right child, we need not do this. Okay, just a second. Okay, right child only, correct only. So if it has only right child, at that time what we are doing is, right, if it has only right child, now the parent who is pointing to left is equal to X or not, we are checking.
Okay.
Okay. And then what we are doing is, that means what here as we discussed, what we said, if it has to delete only one, where it gone? You are able to see Chrome, right? Now,
No.
if it has to, just a BFT tree, that's it, tree image.
Oh.
Now, if it has to delete this 3, you are able to see this. Yeah, you are able to see this, right? Image. Now I want to delete 3. No, 3 has 2 child. I want to delete a node which has only 1 child. 14. Okay. Now I want to suppose this 13 is right child. If you okay, right. Now what okay, I want to delete 10. 10's right child is 14. Right. I want to delete a node 10 which has only 1 child, and that is 14. Now, if I delete this particular child at that time, now my 8 should directly point to 14.
Yes.
Right. Now, if we see this here in your code, here what we are doing, right child is not equal to null.
Okay.
Right. Now, if the parent who is pointing to left is equal to X, which means what here what we are doing is simply we are pointing your parent. We are pointing your parent to point it to directly to 14.
Okay.
Okay. So for that we are doing like, now your parent left is pointing, if it is equal to X, which means the node we want to delete.
Okay.
Then just make this X right as parent's left.
Okay.
Okay. Else if this condition fails, then simply parent's right is here, point it to X right side.
Right.
That means X is right child. Now your parent right is child is nothing but X right child.
Okay.
And then free this particular memory, which is pointed by X.
No.
Okay. So this is for if you have 1 child. Now if both the childs are present. If x is not null, as well as left is not null, as well as right is not null.
Okay.
Now, parent we are just saying it like x. Parent we are assigning x.
Okay.
Okay. Now x as well as parent is same, and now we are seeing like x successor.
Okay.
It is x right child.
Okay.
Now x successor is pointing to your x right child.
Okay.
Now here we are saying that while your x successor left,
No.
if it is not equal to null.
Okay.
If it is not equal to null, then what we need to do is, if we understand this particular thing, here what I said is, if we are deleting a node which does have, now I am deleting E here. E does
Okay.
have both the childs H as well as I.
Okay.
Okay, now your parent here is X, which means now parent is E.
Okay.
Right, and your X successor is, we are pointing it to X right, which means I.
Okay.
Okay, now we will see that your X successor left is not equal to null or not.
Okay.
It is equal to null.
Yes.
Why? Because X successor right. X right is nothing but your I.
Yes.
I is, if X successor left is not equal to null, but it is equal to null.
Yes. Condition.
It is equal to null. Then what we are doing is, we are assigning this parent as X successor. X successor is nothing but X right.
Yes.
So we are saying that now your parent is nothing but your I.
Okay.
Right?
Yeah.
Your parent is now I, and then we are saying that X data is equal to your X successor data, which is nothing but I. And then we are just assigning this X successor to X, which becomes your I.
No.
Okay. So here, whatever node you are deleting, it will be, that particular node will be assigned to it. Okay. If at all, if this, that means after you delete this E, I will take place of E.
No.
Or H will take place depending on our program.
No.
Okay.
Yeah.
This is clear, right?
Yes. Yes.
So this is about your deleting these two different nodes, but here I have to write one function for search. Why? Because we are searching that particular parent, we are searching that particular X found root number we are passing here. So here we need to check that out. I'll just write that program. Meanwhile, before that, already we have so many programs to execute. I'll just execute these programs once.
No.
Just a second, I need one command actually. I'll just take that C files in Ubuntu and then we'll start executing. No. It will take 5 minutes for me to install once again. It's audible, right? audible, right? Is it audible? Is it audible? Okay. So here first we will execute these programs one after the other. So starting with this only, today's three programs only will execute first. Now here we had this array tree. One more function should be there with binary. Binary array 2.c, I guess. Okay. Edit. Binary array 2.c. Yeah. Okay. So this was the first function we wrote, and this was the first program we wrote today. So this is using your okay, this function is finished. So we are simply displaying our numbers now. So this was using array.
No.
Now binary. GCC binary C error semicolon at 11th line. So at 11th line, oh here near struct node, no semicolon is present. That's why we got that error. Could not save. Okay. I'm so sorry. Actually, okay. What I'm trying to do is here. Actually, I'm trying to edit one folder. What I did is actually now this folder, whatever folder I have created on my desktop, which in which I'm using Notepad to write my program, my Ubuntu is crashing continuously. So what I did, I just shared that particular folder in Ubuntu, and now I'm trying to access that. So I'm trying to actually edit this, which is there on Windows.
Okay.
So that's why I'm facing this problem. So I'll just copy this, and otherwise I'll not be able to edit it. Binary array 2.c GCC binary 2.c deleted. Here I have to write a semicolon. That's it. Now, so your array is represented in this way. So our first node is A actually. If we see our program, A is 0, which is the first element, right?
Yeah.
Our tree has to be like whatever we have drawn actually. In this way, our tree has to be A, B, C, D, E, F, G, H.
Yes.
You are able to see paint, right?
Yes. Yes.
Yeah. So our tree has to be in this way. So as we are displaying it in some, we are displaying it using this in order function. That's why we are able to see our output as first D, which is so first we are able to see D, which is sorry, paint. Okay, so first is our D, which is the leftmost node we have, and then we have B, then we have H, E, and then I, and after that we have A, then F, then C, and then is G.
No.
This is your in order.
Oh.
We are going from left, then root, and then right.
Oh.
Right? So you will see this when we are doing this, all this in order as well as pre-order and post-order. That will be simple for us to understand. But right now, I think there is no problem with this particular in order thing. It executed. So I'll just close this and then I'll just go with this next one, which is I think array tree, where we have done same thing, binary array 2, and what is this array 2? Array 2 is done. So I'll just close this binary tree 1, and then this is your array binary tree 2, array tree 2. Okay. Array tree 1. Okay. First I'll see this, what is there in this array tree 1 dot C. Okay, so this was array tree 1 dot C just now. Okay, we executed this only for now. Right. So array tree 2 dot C. Okay, so this is the same function, same program which we have written for only one array in place of 3 different arrays.
Yep.
Okay, so our output should be same like previously we got. This output should be there. Array trees C. Same error we got. Semicolon. See, we got same thing. D, B, H, E, I, A, F, C, G.
No.
Okay, so that was using 3 arrays, and here this is using only 1 array. Now coming to your binary tree, pre-order, post-order and everything. So create it. We have binary tree. 1 dot. So here this we will execute. Here we have seen that post order, pre order as well as in order. So this is your post order, pre-order, in order, and your insert option. Semicolon is there. I hope there is no problem. Okay, no problem. Error at 101. Here I have not closed my main function. I closed. Expected declaration or statement at the end of the input. 101. Doesn't have anything in this. Semicolon. Everything is there. Written 0. I think here it should be no. And in insert function. In function insert. In function insert we have some. This is not closed actually. So this is for this else. So my main here this function is not closed. Now it's closed. Now, if we see this is in order 1, 2, 3, 4, 5. No, we did something wrong. Why? Because everything is same. Everything is not supposed to be same because we are. Let me check once. Binary. Did I copy and paste right? I want to just check whether I have just copied and pasted. Printf pre-order q left, pre-order q right, else written in order q left, printf data, and then here also post order left, post order right, and then printf. Something somewhere it is wrong because in order and pre-order if we get right that is okay. Why? Because here pre-order and post order we should get different output for post order. Why? Because we are going last to the data. That means our first we are going to left and then to right and then to our root. So in our post order this should be 1, but our output is different. Our output is here we should get output like 5, 4, 3, 2, 1. First order, why it is showing wrong? Left, right, and then data. Print in order. Okay. So here I did one mistake, and that is I did actually copy and pasted it. So here everywhere I copy and pasted in order only.
Okay.
So here it has to be in order, pre-order, and post-order. No, editing. Mistake. In order, pre-order, post-order. In order, pre-order, post-order. Right. Out. Now if you see 1, 2, 3, 4, 5, in order, post order as well as pre-order and post order will get different.
Oh.
Okay. So this is our post order. Okay. Now next is your. So this was for binary tree delete option, but in delete I have to write one function. I'll just write that function and I'll execute. Before that I'll just execute this queue, stack and the other programs once. No. So first we will see this link to list.c. We didn't executed any of this actually. So we'll go with link to list.c. There's nothing in this. Okay. Edit. Array operation. Okay. So this was for okay. Here we were doing some operations to on arrays for inserting, deleting, and searching array functions using array functions. Okay. So this function I think we have written 2 or 3 days back. So here we were writing some program to insert an element into an array, delete elements from array, reverse the element from array, as well as search the elements from array. Okay. So we will just do that. It's better to delete the elements afterwards. Better I think. So I'm deleting it at last, and first we are doing insert operation, reverse operation, search operation, and delete operation. Okay, so here we have entered 6 elements. So first let me see the program, whether we have got correct output or not, we need to check. So we are inserting some elements, and those elements are 1, 2, 3, 4, 5 and 7 at starting. So our output at starting is 1, 2, 3, 4, 5, 7, right? So this is our first one. Yeah. Now we are inserting an element at 5th position as 6, and 3rd position we are inserting 45. So that means 0, 1, 2, 3. At 4th position we will get 45 and 5th position we will get 6. So here we got something like insert option 1, 2, 3 at third position we got 45, but we didn't executed this 6, I guess. Third element is 45, which is correct. Why? Because 3 is 45. But fifth element is 6, which we didn't execute. It executed something. Okay, what it did is, if you see this here, 1, 2, 3, 4, 5, 7, right? So here in place of 4, we didn't delete this element actually. So here after inserting 45, it just what it did is it inserted 4 and 5 and it deleted this 7th element.
Yes.
Okay, 4, 5, 7. So I will have to see what is wrong with this. But if you see this here, it has simply, what you can say, pushed it. It pushed this third to fourth, fourth to fifth, and fifth to sixth.
Yeah.
We inserted one thing, and after that, whatever elements were there, it pushed it. Okay, we will see this. And for reversing the operation, so here I think it did correct. 5, 4, 45.
Okay.
1 second. 5, 4, 45, and the other elements it has is 5, 4, 45, 3 to 1. Reverse operation was done correctly. And then we did one thing called the element 3. The element 3 is at fourth position and element 5 is at first position after reversing. Because we have done search operation after reversing the array. So that's why we got this. So this is also correct, and after deletion of some particular elements, which deleted was, which elements were deleted? So deleted elements were first and fourth element, which means here first position is 0 and fourth position is 0. This was also executed properly. The only thing which didn't got executed properly is your insert operation.
Sure.
Why? Because it pushed the elements rather than deleting that particular element. So here 4 was supposed to get deleted.
Okay.
In place of 4 we are writing 45. And 5 and 7 was supposed to be there, but only this particular option. So I think we did something wrong there. I'll just check that out. So we see this insert operation. Okay. So here so we did our operation on third one. So when we did 3, the length was L minus 1, which is 6 minus 5, which is 5. So 3, now here it is 5, 5 is greater than or equal to 3. Yes, true. Okay, so this was executed. This operation was supposed to stop as soon as it reaches 3.
Yep.
Okay, but what happened is, here the length is 5. So the condition was true for 5 is greater than or equal to 3. True, it executed. Then after that L decremented and it became 4. 4 is greater than or equal to 3. Yes, it executed again, and again 3 is greater than or equal to 3. It executed again. So this was supposed to be executed only once.
Okay.
Understood? Here we
Yeah.
executed this operation
Okay.
3 times. So that was wrong actually. Or if we say, if you want to just to push it, it was correct. If we don't want to push it, then we will have to simply insert. Okay, if we don't want to push this, we don't need all this logic actually.
Yeah.
If we write only A of position equal to that element, that would be sufficient. Right?
Yeah. Yes.
Why? Because simply I can write A of 3 is equal to that element, that would be sufficient. But if we want to push the element, then only we will need this. So we will check this also. I'll just remove this while completely. If we want to push it, then we will need this logic. If we don't want to push this, then sorry, the shift is not working. So I've just commented it. Then your position is equal to element. So say the correct file.
I'm coming, okay. Just give me.
Now this executed perfectly. 6 was inserted.
Okay.
Okay. But if we want to push it, definitely we need that logic. Now the next one we have to execute is the operation. 3 operations already done. Delete one I have to do, and the other one we have is now. I'll just make it like .c files. Just a second, because all these are text files. Okay, then I will have to do it. Rather than doing it here, I will have to do it here better. That option is better. Dot text, double linked list. Now coming to your array stack.c. So here we are using array to see your stack. So we are using 4 options here: push, pop, show, and exit. So we have seen this, that if top is equal to size minus 1, then we'll have overflow. If you remember this program, always your top has been initialized with -1. Why? Because always the stack will point to top. So top is initialized to -1. Now we are using this push operation to insert the elements.
Yes.
So if at all, if it is top is -1 and if it is equal to size -1, there is overflow. That means there is no place for elements to be inserted, else it will enter the element and it will increment your top size.
Yeah.
Okay,
Yeah.
so I'll just execute this one. We have an error, expected equal to, okay, I think here we have some last. We have not finished this else. So, still errors are there at 92 line, expected identifier, 94th line output is also there. And the 4th line it's not there. As defined, semicolons are there, main function in choice while of 1, then switch of choice, push, H2, export, default, and then this is closed, I guess. Okay, here the problem is, okay, so I think here the problem should be the function declaration. Okay, why? Because we are not writing this function before main function, we need to declare these functions. Now, but we have declared, right? So, this is also okay. Then what is the problem? 92, 93, 94, before. Somewhere semicolon problem might be there. Equal to the top file greater than or equal to 0 and the first file D of I